Right, exciting Wednesday nights. Here we go. 15. What do we got? A ball A of mass 5 kilograms moving 20 meters per second collides with ball B of unknown mass moving at 10 meters per second in the same direction. All right, that's important. After the collision, ball A moves at 10 meters per second and ball B at 15 meters per second, both still in the same direction. What is the mass of ball B? So, this is conservation of momentum. All right, this equation's a little annoying to write, but I'll write it out this one time. So the mass of the first object times its velocity at the start plus the mass of the second object times its velocity at the start is equal to the mass of the first object times its velocity at the end plus the mass of the second object times its velocity at the end. So let's start plugging in here. Ball A has mass of 5 kilograms. Okay? It's moving at 20 meters per second. Ball B has an unknown mass, and it's moving at 10 meters per second. So since it's the same direction, these can both be positive. If one was the opposite direction, then one of them would have to be negative. All right, this is before the collision. After the collision, ball A, which had had a mass of 5 meters, it's moving at 10 meters per second. And object 2, which we don't know the mass of, is traveling at 15 meters per second. So now this is just algebra. 100 plus 10 m2 equals 50 plus 15 m2 minus 50 on both sides. So 50 plus 10 m2 equals 15 m2 minus this 10 m2 on both sides. So we get that 50 equals 5 times the mass of the second object. By 5, then we get 10 equals the mass of the second object. 16. Satellite A has a mass of 1.5 times 10 to the third, and it's traveling east at 8 times 10 to the third. Satellite B is traveling west, so since these are opposite directions, I'll have to make one of them negative. The satellites collide head-on and come to rest. All right, so they're telling us if these objects are coming to rest, that means that after the collision, the momentum of both of them is 0. Right, so the momentum of the first and the second, they're both going to be 0. So let's just look at the start of the collision, and then we have to set that equal to the end. So we have 1.5 times 10 to the third, and it's traveling east at 8 times 10 to the third. So if I'm saying that east is positive, that means that if you're going west, you're negative. Satellite B is traveling west, so we don't know the mass of this satellite. And it's traveling west at 6 times 10 to the third. So since this is an opposite direction, I'm going to make this negative. And we know that after the collision, the momentum is 0. So the total is 0. So we'll have to do a little math here. So this is going to be 1.2 times 10 to the 7th. And then this will be minus 6 times 10 to the third m2 equals 0. So I can add this to the other side. And I'll get that 1.2 times 10 to the 7th equals 6 times 10 to the third times m2. If I want the mass, I'll divide each side by this 6 times 10. And then in the end, I should get that this is equal to 2 times 10 to the third. This is the mass of the second object. All right, 17. An 80 kilogram skater and a 60 kilogram skater stand at rest in the center. The two skaters push each other apart. The 60 kilogram skater moves with a velocity of 10 meters per second east. What's the velocity of the 80 kilogram skater? So in this case, since both of them are standing at the start before the collision, they both have a momentum of 0. So the total momentum before the collision is 0. Let's look at the momentum after the collision. All right, the 60 kilogram skater is moving 10 meters east. So if I'm using 10 meters east as positive, that means anything west is negative. This other 80 kilogram skater is going to be moving. Now we know from class that if two people on an ice rink push each other, they're each going to move in opposite directions. But we'll still solve it here, and you'll see why that's true. So 60 times 10, 600, plus 80 VF equals 0. Subtract the 600 on both sides. So I get negative 600 equals 80 VF. All right. 600 divided by 80. It's going to be 7.5. VF equals, and this is going to be negative 7.5, but we set this up earlier that a negative, since east is positive, a negative means 7.5 to the west. All right, 18. In the diagram below, a 100 kilogram clown is fired from a 500 kilogram cannon. The clown speed is 15 meters per second after firing. The recoil speed of the cannon is. So this is like a question we had earlier. You know, at the start, both objects are at rest, so the total momentum before the collision is 0. Now we look at the momentum after the collision. Well, the clown is 100 kilograms. He's moving 15 meters per second to the right, so we'll just say that that is positive, which means that the cannon is going to be moving in the opposite direction, so that'll probably be a negative number. So this is going to be 1500 plus 500 VF equals 0. Subtract 1500 on both sides. And we'll get negative 1500 equals 500 VF. Divide each side by the 500. And we get that negative 300. Negative 3 equals VF. But in this case, the negative 3 is going to mean 3 to the east, which is choice 3. All right, last couple questions here. So we have two blocks. Block A moves at the velocity of 2 meters per second to the right and then collides elastically with block B. So you guys should know that elastic collisions are ones where they bounce off each other. All right, that's what it means to be elastic. You get all your energy back. All right. So it collides with block B, which is at rest. Then block A stops moving, and block B moves to the right after the collision. So, question 19. If the blocks had remained together after the collision, their velocity would have been what? Well, if you want to know what the velocity is at the end of the collision, we have to figure out what's the total at the start of the collision. So the mass of the first object is 10 kilograms. Its velocity at the start is 2 meters per second. The mass of the other object is also 10, but its velocity is 0. So before the collision, we have a total momentum of 20. Now, if these two objects are going to stick together, it's kind of like treating them as one object. So there's two ways we can do it. We can do M1 VF plus M2 VF, or we could just add up the total masses, which I'll do here. So the total mass of the two objects together is 20 times the velocity, because they're going to be stuck together, so they'll be traveling together at the same speed. So that's why we can share them like that. So in this case, for 19, it's 1. The final velocity would be 1 meter per second. So this is 19. 20. What is the combined momentum of blocks A and B before the collision? Well, we already solved this. Before the collision, one is moving at 2 meters per second, and the other one is moving at 0. So the total momentum before is just going to be 20 kilogram meters per second. What is the total change in momentum of blocks A and B? So what's the total change? So from start to finish. So before the collision and then after the collision. Now here's the thing. You know from the conservation of momentum is whatever you have at the start, that's what you have at the end. So if you have 20 at the start, then you know that you're going to have 20 at the end. So what's the total change from 20 to 20? 0. There is no change. When we're talking about conservation of momentum, there is no change. That's why it's conservation. All right, if block A is stopped in 0.1 second, the average force acting on block A is what? So this is an impulse question. So Ft. All right, now we know that block A at the start had a total momentum of 20. Right, that's from up here. We figured that out. It was the 10 kilograms times the 2 meters per second. And we know that the block is coming to rest. So I guess I should have written this the other way. Its final velocity is going to be 0 because it's coming to rest, and its initial is 20. All right, and it's happening in 0.1 seconds. And we're looking for the force. So the force is going to be 200. I'm getting negative 200, but that just means 200 in the opposite direction. So choice 3. All right, guys, I hope this helped, and good luck on the test tomorrow.